Hi everyone, I am Mahdi Bahmani. Today we will explore how the Linux desktop works. Linux allows multiple desktop environments on the same system, whereas Windows provides a single integrated desktop shell. This modularity gives Linux users much greater freedom and flexibility. Unlike Windows and macOS, Linux separates the operating system from the graphical interface. This modular design allows users to replace desktop environments, window managers, and even display systems according to their needs. We will examine the graphical architecture, compare X11 and Wayland, understand desktop environments, and learn how Linux provides flexibility and customization. Linux desktop philosophy. The most important concept is that the Linux desktop is not part of the operating system itself. Instead, it consists of applications running on top of a Linux. Linux desktop is modular. The UI runs strictly as a user space application. If your entire desktop crashes, you can switch to a text-only terminal, restart the display manager, and fix the issue without rebooting. You have complete control. You can install multiple desktop environments or window managers on a single machine and choose between them instantly at login. Windows provides a single integrated desktop shell. Unlike Windows and Mac OS, Linux separates the operating system from the graphical interface. This means users can completely change the graphical experience without reinstalling the operating system. For example, some can switch from GNOME to KDE Plasma or XFCE while keeping the same Linux distribution. Linux advantages: modular design, multiple desktop choices, easier troubleshooting, but in Windows and macOS approach, we have single integrated desktop experience. Linux graphics architecture. Linux uses multiple layers to display graphics. Applications or X clients, display server, compositor, Linux kernel, and GPU. As you can see here, the applications, display server, and compositor are all in user space. This magical design allows Linux to implement many OS independent desktop environments. Applications create graphical content. The display server manages communication between applications and hardware. The compositor combines windows into a final image, and the kernel works with the graphics drivers to send the image to the GPU. This separation creates flexibility and allows different graphical systems to coexist. X11 client-server model. Under X11, applications are called X clients. They don't draw directly on the screen. Instead, they send requests to the X server. The X server coordinates window drawing, keyboard input, and mouse events. A useful analogy is a restaurant. The customer places an order, but the kitchen handles preparation and delivery. Similarly, applications request drawing operations while the X server manages the display. Role of compositor. A compositor stores window images in memory and combines them before displaying them. This process allows virtual effects such as transparency, shadows, and smooth animations. It also eliminates screen tearing, which occurs when portion of multiple frames appears on the screen simultaneously. Modern desktop environments rely heavily on compositors for a polished user experience. Demonstration. I'm going to show you the role of compositors and how to activate some desktop effects on Linux Mint with Cinnamon Desktop. On my website, I have an article about this. Here you can see all the steps what we needed. Go on Mint menu and open Preferences. Click on Extension. Here, On downloads, we need some add-ons. Campus window effects. I click on download. And the next one, desktop cube. And another one, burn my windows. I'm gonna first active Campus window effect. Click the plus button at the bottom to activate them. Look at here. The next one, burn my window. I can change close window effect on fire. And desktop cube. And I click on Control Alt Shift left arrows. Look at here. I have some update. I'm gonna install it. You can add more extension as you wish. We could set up hot corners. Go on Mint menu, Preferences. Look for hot corners. Click on. To set up a hot corner, flip the toggle switch. It will light up. To activate the specific corner, choose an action. Here, show all workspaces. I have 4 workspaces. I can active the next one. Show all windows. I can active another one. Show desktop. And that's it. Click on Mint menu, Preferences, and select Windows. Here you can define how would be Alt-Tab switcher style. That's a normal style. I'm gonna change it to 3D style, the first one. Look at here. Or another 3D style. Yeah, that's it. In this way, you could customize your desktop. For each desktop, there are specific instructions. You could read this article later. Data pipeline comparison. This diagram highlights the architectural differences between X11 and Wayland. X11 relies on several independent components communicating with one another. Wayland combines these responsibilities into a single compositor. As a result, Wayland has fewer communication steps, reducing delays and making graphical operations more efficient. Let's look at it deeper. X11 vs Wayland. To visualize the architectural differences, let's look at how drawing data actually flows from your running application to your physical graphic card in both systems. The X11 data pipeline. Under X11, the pipeline relies on multiple handshakes between independent components. The app sends X11 protocol drawing requests to the X server. The X server tells the window manager where the window needs to go based on layout rules. The window manager approves or changes the layout and sends the frame configuration back. The compositor, if active, grabs the window buffers adds visual effects, shadows, and passes the composite image down. The kernel GPU receives the raw instructions via the display drivers and pushes pixel to the screen. The Wayland data pipeline. Wayland collapses the middle layers into an optimized, directed to hardware pipeline. The app renders its own window content directly into a shared memory space and hands the completed image buffer straight to the Wayland compositor. The Wayland compositor, which acts simultaneously as the display server, window manager, and compositor, aggregates the buffer. It also processes input directly from the kernel via the lib input library, securely routing keyboard and mouse actions only to the active window. The Wayland compositor sends the final visual buffer directly to the kernel's direct rendering manager, DRM KMS, which fires it straight to the GPU. Wayland is the modern successor to X11. X11 has served Linux users for decades and offers excellent compatibility. However, its architecture is complex and less secure. Wayland simplifies the graphical stack by combining multiple components into a single compositor. This improves performance, reduces latency, and provides a stronger security because applications cannot easily inspect another application's data. Advantages of Wayland: fewer layers, lower latency, better performance, and improved security. Popular Linux desktop environments. Each desktop environment targets a different audience. GNOME emphasizes simplicity and productivity. KDE Plasma focuses on customization and visual polish. Cinnamon provides a familiar experience for Windows users. XFCE and Mate prioritize speed and low resource usage, making them suitable for older systems or lightweight deployments. Window Manager vs desktop environments. A window manager focuses only on managing windows. A desktop environment includes a window manager plus many additional tools such as taskbars, menus, settings applications, and system utilities. Advanced users often choose a standalone window managers for maximum efficiency, while most users prefer desktop environments for convenience and ease of use. As you can see, a window manager is included into desktop environment. For example, window manager for both X11 and Wayland, Qtile, Kavin for KDE, Mata for GNOME, Wayfire, Enlightenment. And desktop environment, for example, GNOME, KDE Plasma, and Cinnamon. Desktop environments explored. If you choose a full desktop environment, you have several excellent options, each tailored to different hardware and workflows. GNOME Design Philosophy: modern, minimalist, and distraction-free. It discards the traditional Windows style start menu layout in favor of an activities overview, a smartphone-like app grids, and heavy reliance on keyboard shortcuts. Performance: resource-heavy compared to lightweight options. True modern iterations are fully GPU accelerated and highly optimized for Wayland. Customization: moderate out of the box but highly extensible via third-party JavaScript extensions. Pros: polished interface, industry-leading trackpad gesture for laptops, excellent accessibility design. Cons: higher baseline hardware requirements, lacking a traditional desktop icon grid by default. Best use cases: modern laptops, high-end workstations, and users who preferred fluid gesture-driven workflows. Common distributions: Ubuntu, Fedora, Debian, and other Red Hat-based distributions. KDE Plasma, design philosophy, ultimate user empowerment. By default, it looks familiar to Windows users. Bottom taskbar, application menu, system tray, but every element can be reshaped, moved, or rethemed. Performance, medium light. Despite its extensive visual features and animations, modern Plasma is exceptionally well optimized and uses remarkably little RAM. Customization, extreme. You can download global themes, icons, widgets, and window behaviors directly from the settings interface without ever opening a web browser. Pros: visually stunning, incredibly modular, surprisingly low idle resource consumption. Cons: the vast array of setting menus and options can feel overwhelming to a brand new user. Best use cases: power user, gaming rigs, and anyone migrating from Windows who loves to fine-tune their workspace. Common distributions: Kubuntu, Fedora KDE Spin, Manjaro, SteamOS, and SUSE Linux. XFCE Design Philosophy: Traditional, lightweight, and rock solid. It adheres to classic desktop standards and prioritizes speed and efficiency over visual effects. Performance: very light, ideal for minimizing system overhead or reviving old machinery. Customization: high, it uses a flexible panel and plugin system that lets users replicate almost any classic interface layout. Pros: super fast, low RAM usage, and excellent stability due to conservative and tested codebase. Cons: looks a bit dated, lacks modern UI animations and smooth transitions. Best use cases: older computers, low resource virtual machines, or users who want a minimalist, ultra fast workstation. Popular distributions: Manjaro, XFCE, Linux Mint XFCE, Debian, or any other Linux distributions. Mate, design philosophy, a direct continuation of the classic GNOME 2 interface from the late 2000s. It preserves a traditional desktop metaphor while using updated underlying code libraries. Performance: light, slightly heavier than XFCE, but dramatically lighter than modern GNOME. Customization: moderate high. Employs classic multi-panel systems and themes. Pros: familiar, nostalgic layout, very predictable behavior, and low resource footprint. Cons: visual design can feel unexciting and misses out on some modern workflow innovations. Best use cases: users who love the desktop layouts of the 2000s and want the exact experience paired with modern hardware supports. Common distributions: Ubuntu Mate, Linux Mint Mate Edition. Cinnamon, design philosophy created by the Linux Mint project. Cinnamon offers a sleek, modern desktop environment that feels instantly familiar to anyone who has used Windows 7 or 10. Performance, medium, lighter than GNOME but requires more resources than XFCE. Customization, high, features built-in support for desktop widgets, disklets, and panel extensions, applets. Pros, visually no learning curve for Windows refugees, beautifully polished out of the box, intelligent defaults. Cons, can feel slightly sluggish on very old computers, primarily tailored for the Linux Mint ecosystem. Best use cases, Linux beginners and anyone who wants a comfortable, traditional, and reliable desktop setup. Common distributions, Linux Mint and Fedora Cinnamon Spin. What are login managers, display managers? Before you even see your chosen desktop environment, you encounter a login screen. In Linux, this program is technically called a display manager or login manager. It authenticates users and launches the selected desktop session. Its job is simple: initialize the display system, show a graphical login prompt, authenticate your credential, and hand control over to your selected desktop environment or window manager. The names you encounter are simply different software implementations of this concept. GDM GDM3 GNOME Display Manager, the default login manager for GNOME. It features sleek animations, handles user transitions gracefully, and offers deep integration with Wayland. SDDM, Simple Desktop Display Manager, the preferred login manager for KDE Plasma. It supports rich animated login screens written in modern graphic languages QML. LightDM, a fast, highly popular, and desktop-agnostic login manager. It is incredibly lightweight and utilized heavily by XFCE, Mate, and Linux Mint configurations. The beauty of the Linux ecosystem is that there is no single right answer, only the answer that perfectly maps to your personal workflow and hardware. Which desktop environment is for you? Choose Cinnamon if you are moving away from Windows and want an intuitive, polished desktop that lets you feel productive on day one. Choose KDE Plasma if you love software customization, want a beautiful visual interface, and enjoy tweaking your system's finer details. Choose GNOME if you work primarily on a laptop, prefer clean modern designs, and want an interface that stays hidden so you can focus entirely on your active apps. Choose XFCE or Mate if your hardware is older, resource constrained, or you simply prefer a fast, traditional, no-nonsense desktop layout. When should you run Wayland vs Xorg? Choose Wayland if you have a modern computer, especially with Intel or AMD graphics cards, require a strong application security isolation, use a laptop with advanced trackpad gestures, or utilize multiple monitors with varied resolutions and display scaling. Choose Xorg if you rely on older legacy enterprise software that displays scaling glitches under Wayland, use legacy NVIDIA hardware configurations with special drivers, or rely heavily on traditional cross-network remote desktop streaming tools. Nice work today. Let's continue next time with another topic. See you then.